Here's our little how-to of our tough questions on pages 26 and 27. Again, you only want to watch this after you've attempted the problems and you're either checking your work or you got a little stuck and you need a little nudge. So let's look to number 3. This is probably one of my favorite problems we do. The figure below is composed of 8 circles, 7 small circles, and 1 large circle containing them all. Neighboring circles only share 1 point, and 2 regions between the smaller circles have been shaded. Each smaller circle has a radius of 5 centimeters. Calculate the area of the large circle, round to the nearest hundredth, the area of the shaded part of the figure, round to the nearest hundredth. Okay, so let's take a look at that. So one of the key things we want to realize is that the radius of the small circle is 5 centimeters. So that means that right here, from here to here, is 5 centimeters. For A, we're going to calculate the area of the large circle. So we need to do area equals pi r squared. In order to do that, we need to know the radius of the large circle. So if I look at that and I continue and I make the radius of the large circle from the center point out, I can see that really is composed of 3 radii of the smaller circle. So we've got another 5 centimeters there, another 5 centimeters there, meaning that our radius of the large circle is actually 15 centimeters. So as we go to calculate that, pi times 15 squared is going to be 225 pi. And then we want to round to the nearest hundredth. Okay. And that's going to be 706.8. And when we round, 6 centimeters squared. So that's our answer for part A. Okay. Now to find the area of the shaded part, now sometimes students are thinking, oh, that's a circle. No, oh, that's a triangle. It's not a triangle because this area right here is curved, that part. So really what we have to think of is, what if the shading was in all of the gaps? If the shading was in all of these gaps, we could just take the area of the large circle and subtract the area of the 7 smaller circles. But we don't have that. But what we can realize is that there's 1, 2, 3, 4, 5, 6 of these little gap segments. So we can find the area of all the gaps and then divide by 6 to get just that shaded area. Okay, so to start, we're going to do the big circle minus the 7 small circles. We know the area of the large circle. Let's find the area of the small circle. Okay, so our small circle, again, that's going to be pi r squared. We're told in the problem that the radius is 5. So the area of one small circle would be 25 pi. And let's leave that in terms of pi for now. If we're doing 7 small circles, we'll multiply by 7. And let's do our calculation in terms of pi because that'll be more exact and easier. Minus 7, and let's do times our area of our small circles. That's going to be 225 pi minus 175 pi, which will give us an area of 50 pi. Okay, so that's all of our sort of 6 gap areas. To find that one shaded area, let's take 50 pi and divide by 6 because we're only interested in 1/6 of that gap area. So if we do that, that's going to be, right, 50 over 6. Let's see if we can reduce that. That's going to be 25 over 3. So really, I'll just leave it like this, 50 pi over 6. We'll use our calculator, and then we're going to round to the nearest hundredth. So 50 times pi, divide by 6. I'm getting 26.18 centimeters squared. Okay. As a hint for number 4, we know we want to find the area of the shaded region, so taking the area of the circle and then subtracting the area of the 3 equilateral triangles. We know that the area formula for our triangle is 1/2 base times height. What students sometimes have issues with on this problem is identifying base and height. We can see in this part here that our base is going to be 16, but the question becomes, well, what's the height then? And really we have to use this 28 inches right here that's spanning from this part of the triangle to the other end, which would be perpendicular to our base. So if that's 28, then the height of each of these triangles, and this one because it's equilateral, would be 14. Hint for number 5, sometimes people try and figure out, like sort of just trying to find the area of what I would say is the donut, that ring on the outside, but you really want to think of it as that big circle minus the little circle on the inside. And if the garden extends 4 feet beyond the fountain, that means it's 4 feet over here and an additional 4 feet over here. Okay, there's your hint. Now go for it. Okay, now number 6. First thing I want to say is that this number 6 is what I would equate to really a Hall of Fame problem. This is not something I would ask you to be able to do independently on a test or a quiz. You know, this problem's really the reason I'm doing this video. This one is a doozy. So let's kind of really break down this diagram. So we've got a square that's inscribed a circular piece of paper. Inscribed means drawn within. The radius of the circle is 8 centimeters. The circle is shaded on the front and white on the back. My shading wasn't great, so I had to do it in by pencil. The circle is folded over along the upper and lower edges. So this part was folded over, and that's how we have that round edge there. This part was folded over. That's how we have that round edge there. We're being asked to find the area of the shaded figure, so not the white. Round your answer to the nearest hundredth. So there's a few things we want to realize in this diagram in addition to what we just went over. Okay, the radius of our circle is 8 centimeters. So that means from here to here, and all the other ones are 8 centimeters. I also want to notice that these lines that should be pretty faint on your diagram, you might want to draw it in, are perpendicular. Okay, and within that, the radii I see really kind of constructs a triangle here where we've got base and height both of 8 centimeters. So my first step here is I'm going to find the area of the circle. And I'm going to leave everything in terms of pi for as long as I possibly can. So pi r squared, we know the radius is 8, so our area is 64. So we've got an area of 64 pi for the full circle. Then what I want to notice is we've really got a quarter of a circle here and then another quarter of a circle there. Knowing that area might be helpful to us. Hint, hint, it is going to be helpful to us. So let's find the area of our quarter of a circle. So to find that area, we're just going to take our area of our full circle and divide by 4. So we already know the area of our full circle from before is 64 pi. So really we can just do 64 pi divided by 4, which is going to be 16 pi. Okay. Then I also pointed out that little triangle. Okay. That little triangle is going to be helpful because it's going to help us to figure out these sort of empty flaps there. So let's find the area of our triangle, which we know is 1/2 times base times height. And we identified the base and height in the triangle from the radius of the circle. They're both 8. Okay. So it's going to be 1/2 times 8 times 8. So half of 64, which is going to be 32. Now in our diagram, I kind of want to talk about these flaps. And I want to imagine as if the flaps hadn't been folded over. So these little shapes, I would have had 1 and then 2 as it folds over, 3 and 4. Really thinking about those pieces that are missing from the triangle. I have 4 of those little flaps. And my next step is to figure out, well, what is the area of one of those little flaps? So to figure out that flap, what I'm going to do is I'm going to do the quarter circle minus the triangle. So the quarter circle minus the triangle is going to show me that missing flap there. Okay, so to figure that out, let's do, right, because we got our quarter circle, there's our triangle, that'll give us this shaded area here, which we see replicated 4 times. So our quarter circle was 16 pi, our area of our triangle was 32. I can't combine those right now because those aren't like terms. I'm gonna leave those as a binomial. Now, to get our answer of the shaded region, what we're going to do is we're going to take this imagined big circle, the full circle, and I'm going to subtract out those 1, 2, 3, 4 flaps. So our shaded figure, we're going to do the full circle minus the 4 flaps. So our full circle was 64 pi. We're going to subtract and then 4 times our area of the flaps, and I'm going to put it in parentheses because it's a binomial, 16 pi minus 32. First step, we're going to distribute that 4 to simplify, which gives us 64 pi minus 4 times 16 is also 64 pi, and then 4 times 32, and negative 4 times negative 32 is going to be positive 128. And those 64 pi's cancel out, and we're left with our area of the shaded region, which is 128 centimeters squared. Okay? Now, again, this question, this is next level stuff right there. So if you were able to follow it and understand it, you know, feel good about it. If you struggled with it, don't feel bad about it. This is really sort of something, I would say, more high school level geometry for us, not something I would ask you to do independently. Okay, so let me know if you have any additional questions, and I'll talk to you guys later.